Now we are going to evaluate this integral, that is very important. What I am having in the denominator, when taking this denominator equal to 0, we are getting z square minus 1 into z square plus 1 equal to 0, that is z equal to plus minus 1 and plus minus iota. How many points lies inside this circle among these? All the points lies inside this circle, because this circle is having the radius 2. So definitely all these points lies inside this circle. So we need to use a Cauchy's integral formula for all these points. Now for this, we need to check what is f of z. F of z is always equal to the numerator, provided all the points should lie inside the circle when taking this denominator to be equal to 0. So to apply the Cauchy's integral formula, we need the values of f1, f minus 1, f iota and also f of negative iota. We need all these values because our function is already a constant. So for this constant functions, whatever be the value of z, all these functions at all these values of z will be equal to 1, right? Because function itself is constant, whatever value you put over here for z, you get all these values of f at any point of z to be equal to 1. Okay, let's move on to the solution. What is our integrand? It is 1 divided by z the power 4 minus 1. Let's first make the partial fractions for this. So this is z square minus 1, z square plus 1. Separating this, z square minus 1, z square plus 1. When taking this to be equal to 0, we get z square equal to 1, right? So when you take this to be equal to 0, hide this from the denominator and put z square equal to 1 over here. What you get? 1 by 2. So this is 1 divided by 2, right? Similarly, when taking this denominator to be equal to 0, we need to hide this from the denominator and we get z square to be equal to negative 1. Put this value in this fraction, what you get? Minus 1 by 2. So writing here 1 divided by 2 into z square plus 1. Easy? Okay, let's take 1 by 2 outside and now writing this z square minus 1 as z minus 1 z plus 1. Similarly, z plus iota into z minus iota. Again we need to make the partial fractions for this. Writing here z minus 1, here z plus 1. When taking this to be equal to 0, hide z minus 1 from the bracket and put the value of z equal to 1 here. We get 1 divided by 2. And when taking this to be equal to 0, hide z plus 1 from the denominator. We have here z equal to negative 1. When putting z equal to negative 1 over here, what we get? Minus 1 by 2. So writing here minus 1 divided by 2. Similarly, we make the partial fractions for this also. Writing here z minus iota and here z plus iota. When taking this to be equal to 0, hide z minus iota from this bracket and putting z equal to iota over here. In this fraction, what you get? 1 divided by 2 iota. So this is 1 divided by 2 iota. Similarly, when taking this to be equal to 0, we get z equal to negative iota. Hide z plus iota from the bracket. Z equal to negative iota, when putting over here, we get minus 1 divided by 2 iota. Please take in mind, we are taking this negative sign outside of this bracket. If I take this in the bracket, let's take 1/2 common from all these terms. We have 1 by 4 outside of this. So in place of this integrand, I am going to use this value. So our given integral become, so this will be equal to 1 divided by 4 integration 1 divided by z minus 1 dz minus integration 1 divided by z plus 1 dz minus integral sign let's take 1 by iota outside. 1 divided by z minus iota dz. 1 divided by iota integration of 1 divided by z plus iota dz. Let's evaluate now all these integrals. We are having our fz to be equal to 1, right? This is your fz. So this is equal to 1 divided by 4, applying the Cauchy's integral formula for the first integral. That will be equal to 2 pi iota f of, I'm having the point here, 1. F of 1. Then applying Cauchy's integral formula over here, what is the point you are having? Please remember the format z minus z naught. So here z naught point is now negative 1, right? So this is minus 2 pi iota, writing f of minus 1. Then minus 1 divided by iota. Okay, applying the Cauchy's integral formula for this point. What is the point here? Z naught is iota. So this is minus 1 divided by iota, 2 pi iota f of iota. Plus, here the point is, z naught is negative iota. So writing here plus 1 divided by iota, 2 pi iota f of negative iota. Let me take 2 pi iota outside. It is common. So we have f1 minus f of negative 1 minus 1 divided by iota f of iota plus 1 divided by iota f of negative iota. What are all these values equal to? All these are equal to 1 because our function itself is constant, which is equal to 1, as fz is constant function. This is a reason for this. So this is equal to 1 divided by 4, 2 pi iota into all these values are equal to 1. Minus 1 by iota plus 1 by iota. So this is cancelled out with this is also cancelled out with this, and we are getting this to be equal to, this is pi iota divided by 2 into 0. So that is equal to 0. Again we are getting the answer for this given integral to be equal to 0 as in the previous example. Alright, thank you. Stay blessed.